Hello everyone, welcome to Dev Machine. This is another version. We're at version 0.99.80, close to getting there, close to version 1, close to finishing everything, but there's a lot more that I still want to do. So I'll talk about what's new and I'll talk about what's to come. So first off, you've got the print extended node. This is a new feature that is a bit more than what macro print does. Macro print will just give you text. Now you can choose an asset for text here. You can choose the starting point of the text and where it ends. Okay, so since there's nothing in here, I'm just going to edit, and well, we've got something like this is a test. Okay, and close that. Okay, we can say we want it to start at the second character, and we want it to end at the 9th character. I'm just going to get rid of that. And the program will crash if you don't put in an RTS here. If you watch my previous videos, I talk about this RTS returns it back to basic, or you can put in a game loop. You can use the org block to continue code, so you can carry on your code down the way here. But to be organized, to use these org blocks, you just press O to create more of these, and the code will flow down this one, up to the next one, and so on. If you did want to move your code blocks around the place, I advise wiring them up like this, so that they will stay in the same order, because they're used to moving from left to right. Okay, you can double right click to get rid of those. So I'll get rid of the RTS, and this will just be a loop that holds it in place. You can see the difference when I run this. So it's going to say my message. You see it says LLO war, right? Because I chose the start letter and the end letter there, LLO WR, right? So that's what happened there. So you can just basically turn them off, make them 0, right? 0 is just auto. It's just going to show you the whole string. Okay, this is a test. Now, the other thing with that is you can clear the screen. Just click this, it will clear it beforehand. You can set whether you want it to be default using these two here, or you want it to be centered, top center. So it should now show that. It'll clear the screen and it will be in the top center up here. Okay, so that's how you do that. And the other good thing is it's going to tell you the address of this particular text. So it tells you the address of where it comes from, but also the address of the X and Y. So for example, I could put in 10 here, and you can see it's 040A, and the color location is DB0A, right? So this is a good way to sort of figure out where does this live in memory, this particular one character, right? DB82. And for example, if I was to type something and not like using these defaults, so this will now print this text at 10,5, so 10 across and down by 5. We go there, right? But it's giving me a reference to the first character. 04D2 is that first character, and DBD2 is the color for it. So I can kind of like hack this if I want to change the color from the first character. All I have to do is an LDA. You can use this lookup table to figure out the color. Let's say I'll go for 0D. And I'm going to store that in D8, D2. Right, and this will just hold the game in place. So I should effectively get a green character. Like, there you go. So that's that first character there. So it just gives you a reference to it so that you can use it for routines. Now, if I wanted to color all of that, it makes sense just to choose the color here, right? I'll just choose what I want like so, and I can color it that way. But it's just a nice way to know where that actual character lives. That'll be useful later. So that's macro print essentially. So talking about the extended one, this one can show you a variable or registers. We can look at the X, Y, stack pointer, flags. Flags are kind of handy, and you can look at them in hex or binary, decimal. So the right way to look at flags is in binary. I have no idea what they would look like in other formats. So we're just asking to see what all the registers are. NV, BD, IZC. That's your negative flag, your, I forget which one that is now, your negative flag, branch, decimal, interrupt, something, and something. Yeah, I don't know them all to be precise, but I will look that up later. just escapes my mind every now and again. The carry flag, there was that last one. Okay, so I'm going to let you do your homework on that. I'm going to see what happens when I do BCD for this. Okay, it just defaults to showing it as binary. I think this one has an exception that you can't show it in any other format, if I'm right. Yeah. So you would use you can use that to see what's in the A register. So if I did an LDA 0F, in theory, we'd expect to see 0F when we show this as decimal. That's 15. There we go. All right. So it's actually done that, which is quite interesting considering there's a lot of code in here with already like accumulator based stuff. But let's just test that again. Let's do 0A, which is 10. And there we go. So that all works quite nicely, thankfully. We can also show what's in a variable. So we can create a new, let's see, a new byte and call it my byte. Right, and by default, it will just read what's in that location in memory, which might be 00 or FF at this point in time, until we actually set it. So we're going to set that variable, my byte, to, I don't know, just do 50, oh, we'll do 64. In fact, let's do 64, like so. Notice that when you type this in without the $sign, it's assuming that you're typing in decimal, which is nice, right? Because that will convert it automatically based on this mode. Or you can press X to toggle that as well. So 64 is what we expect to see in decimal. And the variable, we have to pick it. We can also pre-clear the screen as well. But there we go, 64. So this is handy if you want to show any debug information, a score, for example. So if I did want to show a score, I could do character set and copy the ROM file, and basically then do something with the numbers to make them look more interesting. Okay, something like that. Doesn't have to be exact. So now you can see I've got a conflict between the character set and text data. Text data is getting its information from basically 2600, and the character set is living there. So I'm just going to move this text data. Let's just move it to, I don't know, 1A00. It doesn't really matter where that lives. It's just general data. Right, so I've moved it well before it and got plenty of room for code. If there's any other overlaps later, it's simple just to move things around. Most of the time that just works. Okay, so we're going to look at our variable my byte, and we're going to look at it with this different character set. Now if we just run this, it's not just going to replace the ROM character set, right? It's still built in memory. We have to tell it that we want to use our character set. So we can go here and say, well, let's choose our one, like so, right? And that should hopefully just work as well. Right, there you go. So we've got our funny, you can see all the numbers have changed. And of course, we can go even further and change the whole alphabet if you wanted. So if I change this C to something like the little Commodore logo. D, let's do everything in that style, like a kind of a Commodore styled graphic, right? So I'm trying to be a little bit artistic about it. G, B, let's do that, etc. Right, so that will change A, B, C, D, E, F, and G. So if we run that now, you go, all our little C's and D's and E's are changed. So you can totally stylize your screen if you want your font. Simple as that. So that's macro print extended. You can use it to see states of the machine. You can use it to look at variables, to print scores or whatever you want to do. If you are doing a score, that's more likely going to be a BCD that will print 6 characters. That can go up to 999999. And you can always fake a little 0 to the right of that if you want it to be 7 digits. Or another 2 zeros, depends what you want. Right, so that's all good. I'm just going to reset everything. Now, let's see what's next. So a lot of the other things are still what they were. There's plenty of tutorials on them. We've got sprite, move. A new thing is seek. Now, seek is a one-shot call, so you put it in a cycle, or you JSR it if you want to go and fetch it that way, to update the position of a sprite or sprites to go to this point. So we need a sprite for this, so let's create one. Let's just add a sprite node, add a sprite set. You can see this is all optimized down to just single sprites. So I'll make this into a little Commodore logo. In fact, I'll make it into Dev Machine logo. So I'll clear that and I'll use lines. Okay, so it's going to be my logo to test with. Let's just pick that, and there we go. There it is. It's loaded into 2800, which puts the sprite pointer down at this end, and you can see it's marked down there. As we come down to this bar here, we can see a few notes and labels. Okay, so the sprite is set. That will just show, and macro seek needs to be in a cycle, like I said. So let's just put our cycle here in the org block. What I like to do is do all my initialization in that block, maybe even have 2 of them, so you'd have like it jump to an org block and do all that, and then just flow into your loop. So this is going to basically tell this sprite, which is living at 128.128, to go to 160 by 120 at a speed of 2. It uses 4 directional movement, which is just up, down, left, or right. Once it gets to a near distance, we can make it go faster if we want, but that's off by default. We can emit the distance and angle to another variable for checking for other things, like is good for AI. And we can also enable a 9th bit to make sure it goes beyond where it should. And wrapping is kind of optional. It's up to you whether you want it to be bounded to the side or it will try and move beyond that, but it's more likely that you'll just leave that on wrap, because I think it is slightly cheaper. Yeah, just leave it on wrap, I would say. That way you won't get stopped at the edge. You can always work that out later. So macro seek is going to move this sprite. Now I do need a V weight. You can do Alt V, or you can drag it in from here. Right. So I like to just put it before. That way it's going to wait till the screen's finished before it does the next thing. Look back round, wait till the screen's finished before it does the next thing, and it just does that forever. So all we're going to see here is this sprite moving to this point, and it should go relatively quickly. It's moving at a speed of 2. There we go. So it went right, then up, because we get the 4-way directional movement. Now I'm going to move it right right past the 255. We'll go all the way to the right, and we'll go all the way to the bottom right. There we go. It's went down to 200 there, and you can see you could probably push it a bit further because I think it's measuring it from the bottom or something like that. So you could probably go something like I'll do 230 to see if it goes beyond the border. It should go out just a bit. Oh, it's just right there. So there's something maybe not quite right with the offset position. I'm pretty sure that it is 21 characters, but do you know what it is? So this is measured in not just the background, but it's also including the border, right? So you have to think about that as well. Okay, so that's 4-way. If we change that to 8-way, we can see it does cost less to do 8-way. So I'd recommend that. It just depends what you need. If you need something that needs to stick within certain rules, then 4-way kind of solves the problem for you. If you imagine like a perpendicular maze or something, like you only go left or up, then 4-way would suit that pretty well. So 8-way, you'll see now it will go diagonal, which is more for like an open space. It went straight to that point, but at 45 degrees, right? That's the only way it really works, is in 45 degrees or 4-way. So let's just make that a bit more apparent. Let's do 300 by 200 again. And we'll see it will move a bit differently. So it should go diagonal first, then across, right? So that's the way it works. I've not decided to do it any more complicated than that. I did try to do like vectors where it goes directly, but it was too much calculation to do that. It was too many bytes to make that work effectively. So I decided against it and keeping it simple. So you can move whatever number of sprites you want to. You can see the more you move, the bigger this gets as well, because it's having to do this for each. But there might be other ways to do this, like you could literally get this sprite's position and give it to another sprite's position, and I could update this node to do that, because right now that's too much. It's treating everything as individual sprites. So for example, if I was to copy this and change it to sprite 1 and move this up to, let's say it was at 200 and the Y was at up to 18, it's going to move these individually. That's why this becomes more expensive, because it's actually treating them like different things. So you can imagine that if you had 8 missiles around the border of the screen and they were all designed to go to your location, which you can totally do, you can have this be variable driven, which could be your player's position, and they would eventually go towards you, right? So let's just do that. You'll see that these will now be 2 sprites, and they're all going to the same point, right? One came from below, I think. Oh yeah. So this one started at 18, kind of came from the bottom, I guess, because it must have moved from the top because it was the shortest route. So you have to be mindful of that it could take a bit of a shortcut and move that way. So Y18, let's just do Y58. Yeah, see, it took the shortcut there because we got this wrap mode on. I'm pretty sure if I did bounded, it will go a different way. Okay, that's obviously a bit bugged because it didn't think to do it any other way. So it's a new feature and needs a bit of work, I think, but you get the idea. So you can move more than one sprite at a time. You can choose this bounded or wrapped, 8 direction, using variables. You'll notice that I'm clicking after I do something because that forces all the byte information to update, not just a click here or wherever. So usually I click and then click again just to get it to be forced updated. Depends what it is. Right, so that's macroseek. It's really handy for basically moving stuff towards a point. I don't recommend I don't recommend doing it in too big a distances, because you can see it can just like go out of the screen, come back in. I obviously need to work on the bounded feature where it's not trying to use the shortest route. So that's a new feature that needs a little bit of tweaking, but you can use it right away. It's already in this version. Okay, so I'm just going to clear everything again, talk about other new features. So let's clear that. So we got collide, as I showed before. This is a simple collision where you do sprite to sprite tests, sprite 0 hitting sprite 1, for example. What happens if they hit? It calls this GSR, which you would return from. Very simple stuff. Hit the background, same idea. You just have to declare which sprites are hitting the background. You don't need a group B for that. But if you're doing both, then you're testing the hit case for sprites hitting each other as well as hitting the background, for this group A at least. So that's that one. Collision Advanced is obviously very advanced. This has been changed recently, where you can actually put variables into these probe points. So I've got a bit of an example of this, so I'm just going to load that up. Okay, and I will talk about this a bit more. So this is just a map choice, map chosen flag, positional stuff that I don't even think I use anymore. The animation loop if it's done, reading the joystick for the initial fire button. And these are the two I want to sort of talk about. This is probe X and probe Y. These are basically two sign bytes, so they can be negative or positive. It's just the kind of variables that you should use for negative and positive values. Basically, if you do a -1, it's literally just 255 minus 1, it becomes 254, but it splits it in half, so you get 127 positive values and 128 negative values, something like that, and a 0. So that's kind of how that works. So I'm just going to show you. This is the collision check routine that I jumped to, that I GSR, I subroutine to it, and you can see it's using these variables. So if I take these out, if I clear them, it becomes just a normal probe again. Now you notice something there. If you click twice, it zooms in this box. That's a little bug where I need to make sure you're not clicking on a node for that. So I'm going to work on that, but in the meantime, I'm just going to move that out of the way, and it won't do it, right? So I can double click here all I like. So just be mindful of that. So you can choose the probe point when you're doing a collision sample. If you just have a single probe point, that's fine. Like, it might just be the center of your character, right? When he hits something, it's always just the center. But I do recommend, if your character's moving left and right, that when he's moving right, you're probing to the right, and then when he moves left, it's not that same probe point, because what will happen is he'll get stuck on the wall. He won't be able to move because he's still essentially touching it. So you change your probe point depending on what way he's moving. Now, this was expensive to do this for each movement. This was initially, if I show you the previous version, okay, this was initially, let me turn all that off. You can see it's in each direction. So these are all the joystick calls, up, down, left, right. They go here, they do all this stuff, and then they return back to this macro. So what I was doing was checking the collision for sprite 0 and seeing, so this would be walking right, I believe. So when the character walks right, it's kind of at his foot. You know, if he touches a wall, or his feet touch a wall or whatever, he would basically stop. It says to skip the move, so it carries out this feature of these marked tiles, and there's certain tiles that are marked with this T1 inside the map. Let me just show you that. So there it is there. You can press spacebar on this to go through them. You get 8 different tiles that you can mark, and that's basically that. So if he touches this tile, it will jump over the move and jump to the skip move. In fact, it's over here. So it actually jumps back to this, and I I've just realized something that might actually upset the stack looking at this, because this is expecting an RTS. So I need to think about that a bit more. That could get quite bad because it is actually jumping over here, and this is the dispatch call, and it says it's going here, and these are also JSR. So I don't know what might happen with the stack here, but this looks like it could be a bug later. So I'll keep my eyes on that one, because you know this tool is still evolving. There's still little edge cases that I've yet to uncover, but I'm going to assume that it's fine for now. But if I was to check out the stack pointer, I might see otherwise. Okay, so that's what happens there. It was doing this thing, right, and jumping back to the skip move. And in theory, I think it would be better for me to skip to something like here and then go back. That way I'm still hitting that RTS correctly to come back here. That would be the right way to do it. But you can see I actually redid this anyway, just to have a JSR call to this here. So this similar thing will happen if he's going right, and then we get the animation update. We're updating the probe offsets, so we're changing the X offset and the Y, which is now being fed into this. It says it's using vars, and that's now then going to do the collision check. Goes up there, comes back, then it's allowed to move, and it moves the amount that it should. Okay, so if not, if this was to hit that tile, it actually jumps back to the skip move. So there's a bit of again, it's the same stack bug, potentially, if I'm JSRing to this and not reaching the RTS and going back here and reaching this RTS, essentially it's going to jump back to where it was called from, which would go back here and hit this RTS anyway, which is a kind of a bit of a spaghetti network of jumping to a routine and jumping back. So I'm going to keep my eye on that. It's not caused a problem yet. I might be lucky that I've just kind of made this kind of twisted loop, so to speak, but I'm not too sure about it. It would need to be tested more, but I'm just going to show you what this does. So if I hit F5, it is a silly little, I don't know, Benny Hill spoof thing that's just sort of came about. So there's this screen. I put this little sprite in just to show you I could get a sprite working with a bitmap. Press the button, press space or fire. It's fire button actually. Press fire button to come to this screen, and there we go. So we're colliding those tiles and we don't get stuck. Okay, so we can go left and right, up and down, and we never get stuck because the probe point always changes. Right, so we're essentially in a room. The only thing to do would be to mask it out when it hits these, like to make it look like it's overlapping, but I've not figured that out yet. That'll be a bit more later. But yeah, it all works quite well. I say I don't have any corruption with the stack, and I might just be lucky with that, but we need to keep an eye on it. Okay, so that was that's basically that new feature with these, but these are in the new version. You won't get access to these just yet, so you'll be stuck with just the single probes for each, which is quite expensive. So this is 224 bytes versus the previous version was 195 for each. So you know, do the math, that all adds up to about 800 compared to one that's less than 300, so we save a lot. Okay, I'm just going to reset this and talk about something else. So priority is sprites in front or behind the background. Now that might be useful in that case there where we wanted to be behind the background, but I might look at a sprite masking feature later. So you got priority, it's going to show in front or behind which sprite. Enabler, you're going to show or disable sprites, you can hide or show them. An expander to expand X or Y of which sprite. Animation. Okay, so animation is slightly different. You actually go back to that example. I'm going to show you the animation, how that works here. So this one just animates this face, right? This is just in sprite 1. Let's put it in slot 1 for for some testing. I left it there. So it's just going to go 0 1 0 1 0 1. That's all it does. right? And it's a looping animation. The loop is checked. You just call it with this routine here. So it basically does the init, music, unlocks RAM, sets a border, initializes the probe points, shows the bitmap, shows this new sprite and sets it all up, and then sets up the animation ready for calling, right? That's the right way to do animations. Don't put them into your loop itself. It's better that you treat them as init GSR called, as it says there. So you initialize it and then GSR call it. Now you can see this one's different. I've got looping off, and what it does is it gives me the animation to routine similar to that one, right? This is the ID of this node, 100, 104, which GameMaker creates, so we use that ID quite a lot. And then this is to reset it, because it's not looping. If it was looping, it would be resetting itself, right? But this is the call to reset it, and it emits its done state to a variable that we create. So that's why we created this anim loop done, and it just means that I can use that, which you'll see that I do use at some point to see if the animation's finished to reset it. Here it is here. So if it's not equal to 1, it's not done, then we're going to skip resetting the this here, which is this call here. We're calling that exact routine to reset it. So if it's not done, we're jumping over that, so it just carries on. Okay, so this is just playing 1, 2, 3 different frames for each, and the looping's off. This is the delay for the animation speed, and everything else I guess is just normal. 9th bit toggles are these checkboxes here if you have to go past 255, and everything else is cool there. So that is that one. So let's just reset, see if there's anything else. So that's animation. Flip X will flip sprites in memory on the fly forever. So basically, if I have a sprite, let's load. Let's just do another sprite set, and I'll just do a little arrow like that. Okay, so you know I've drawn that facing right, and I'll bring that in. Right, and this code will basically say, okay, from 2800 for a count of one sprites, or just one sprite, I'm going to flip that whole chunk of memory from left to right. So it's designed for sprites. You can't just flip everything and expect it to work. It will flip the data, but it's designed for sprites. Okay, so it will detect if it's multicolor or single color and do all this math inside of it to flip it correctly. So we should see, if I do, I'll just do an RTS, go back to basic, we should see a flipped version of that when we run it. Okay, there you go. So it's a flip version. It's very fast. In fact, if you wanted to see how fast it actually is, we can do an A and a J. And in fact, it's already initialized as sprite. So we just want to do this, right? And we don't need the RTS. We've got a loop here. I like to tab those in. So it's going to set up the sprite and get to this loop, and then it's going to keep flipping the memory. You see how fast it is? It's going so fast that it's just like a blur. So it's kind of a nice way of getting like a mix of something. So that's how fast it is. Obviously, if you put in a V-weight, which you'll more than likely have, that'll be a bit more stable. So we're going to wait until the screen's drawn. But it's still pretty fast, right? It's still running at 60 frames per second. So you're seeing 30 pointing that way, 30 pointing that way within a second. And it's alternating. I can do Alt-P and Alt-Shift-P. You can see exactly what it's doing. Every step it's flipping it. All right, so that works really well. It's not a too expensive routine for 10 sprites. It's so if I wanted to flip 10 sprites, it's 392 bytes. So I don't have to make mirrored copies of my sprites. So it turns out cheaper. I think the cutoff point's about 8 sprites. Let's see, 8 is 390. Let's do 9, 391. So we're at 400, like each sprite is 64 bytes, right? So it would break even when it reaches that. I mean, it's always, you know, I've done a full bank of 64, right? 128, I think there's a cap to it. But there you go, you can flip 128 sprites for 510 bytes, as opposed to 64K worth of sprites, right? If you need flip versions, something that is. But it's a handy little one, right? It's a handy tool to have if you want to just make all your sprites just facing right. They're all walking right, running right, jumping right, and you decide to move them left. You do a little one-shot call of this flip, and it's pretty fast. You can do it every time you change direction. So you'll have a flag to say what direction you're facing, and compare it with this. If it's changed, compare it with 0, then it's going to be, okay, it's facing right. Compare it with 1, okay, it's going to be facing left, and so on. And you can use that flip accordingly. Right, so let's just reset that. And let's look at SID. As you know, just plays the SID track. You have to put a little RTS in there, and you'll hear something. You won't hear anything unless there's something loaded into memory. Okay, so there's nothing playing here. And we can load in a SID. Let's just do SID music and see what I've got. Devs, SIDs. Got a little 2-channel. I've got a few other ones here. This one's from a game coming from Megastyle called Operation Vostoka. And I'm pretty sure it should just play without setting it if it's the only SID. Something that I did notice. Yeah. And I don't know if that's a bug or something. But essentially it's already loaded this into memory, it being here. Then that might be a bit of a bug with my code, because it should only load into memory if you choose it. So you might not want to use all the assets. You might want them all sitting there, and then you want to choose which one you want. But basically that's how you would choose it, right? If you had more than one, you would choose it like that. So it just plays that. Now there's a lot of things that depend on a SID, like a text scroller will tell you need a SID because it uses a feature, an interrupt from the SID. So you can just bring in a nothing SID. Right, it does cost a bit. It costs 144 bytes just to get that routine going. There'll be cheaper ways to do it, such as using interrupts and the interrupt shell. But that's, for me, that's even more expensive. So I just use the SID for that, an empty SID, and you can do your scroller stuff there. And the text scroll, you can have a GSR mode, which you can call in a loop as opposed to just ticking with the SID. So you can actually GSR this. So if you press J on the node again, it becomes a GSR, and then you can look up your scroller there, and now it's not flashing anymore. You can set an alias to give it a name if you want, like, instead of that there, say my text, right? And it says not called again because it doesn't auto resolve. You have to choose it again. So that sets up the scroller. It gets caught in a loop, and it's going to call this, and then you just need a V-weight in there, and that will also work with the SID, even if it's GSR called. But it just helps you kind of control it along with other things. So if you had like joystick input, you basically need to have it in GSR mode. So you can turn that off, right? It will crash because this is going to be looking for something that it can't find. Well, that's fine, right? So, but that's essentially just that's just going to tick all the time, and yeah, that's all you can really do. So, yep, that's all good. You can mess about with that. You can do your text as an asset or in line, similar to what I showed you before with the print macro. I'm just going to reset this to talk about the next thing. So we've got track, just selects a track. So if you've got a SID, you can select the track here from the get-go what track it's going to play, but you can use this at some point in the game to change the track. For example, if you had a death sound or something like end of game or a high score track, basically you put them all in the same SID, but they're all like they're all flagged for which track it is, and Goat Tracker works very well that way. Okay, so that is that. Let's see, sound effects. Sound effects again needs a SID. I'm pretty sure if you don't do that, it'll tell you add SID macro. So again, that depends on the SID. You have to load in sound effects data, which comes from a Goat Tracker file. So I have Goat Tracker files here, sound effects, big load of sound effects, and it just excuse the foul language used for these, but these were all just silly tests. I just put in random numbers. But basically, you do that. You would choose your sound effect this way, right? And it just plays that. There we go. We can play pushy and pee and plop, and so it was just play the music and play that sound effect. and I'll do an RTS to see what happens. We should hear something. I don't know what. Yeah, it was like a zip, basically a nothing sound, because it's just random numbers, like I said. Let's see if poop sounds better. Yep, we got something, a little beep from that. I'll talk about making sound effects in another tutorial as its own thing, and goat tracker and all that. It's very cool. Loaders, these are all to do with disk management. So for example, I could have a disk load these in, although sound effects data I'm pretty sure is different. It shouldn't be allowed on a loader. I'll need to look into how I do that. It might be okay, maybe okay. It should be okay because it's just a sound effect. But yeah, the loader's fairly new as well. So you would have a bitmap, for example. You would have your load org and basically say what you want to be on disk instead of loaded immediately. So you would add, bitmap sound effects. It tells you what's in there and how much data that uses up and stuff like that. I'm pretty sure sound effects data, you can see it's like 1 byte, 1 block. I'm pretty sure that's not been done properly yet because the way it sort of decompiles, if you like, internally that goat tracker file to make the instruments up. It still has to be finalized. So that's a note for me. So I will work on that. If node, you can choose, you can compare two variables now instead of a variable with a value. And then once it does that, it goes to a place, right? It also springboards so that if where you're going to is very far away, like more than 128 bytes away, I think it is, then it will springboard itself automatically, and it's got all these functions in it as well. So that all works nicely. I'm not going to talk about how to use it. It's kind of self-explanatory. Get var, set var. Get var will just load the variable into accumulator. Set var will put a value into a value, and you can choose whether you want a variable value into it. So you can look it up and you can set a variable with a variable. That's quite a good one. Inc and dec, self-explanatory. Different bytes, they're fine. And I guess we're on to these last two. Move memory, similar to well, it's similar to flipping the sprites, I suppose, but you can actually move memory around. So if I had I don't know, some tiles in an area in a map and I want to move them, then I can use this. If I knew where they were in memory, I can move them to another location. I can move stuff to the screen. So I was messing around with that actually. So let me just right click these. Oh, sound effects in use, is it? Okay, the load arg is hogging it. Right, let's get rid of all them. Now, so I'm just going to talk about this a bit more. So I'll just run this, right? And you'll see that we've got some data up here on the Commodore, right? This is all data in the screen area. And I can basically kind of just copy that about. So the screen memory goes from in hex 0400 to 07FF or something like that, right? So I'm going to just copy a chunk of it. I'll do 0400 to 0500, which is the first 255 characters, I believe. And I'm going to copy it to the next row. And I'll just do an RTS there because if I have code here, I need it won't auto inject an RTS for me. I need to put one there, and that should copy all this stuff down here. It's kind of silly, right? But yeah, that just works. Obviously, I can choose where it actually lands a bit better, like 4AO or whatever. Right, it should maybe be a bit more aligned. There we go. All right, and I can do that again and again if I wanted. Instead of the RTS, I'm going to do a loop so that we don't see the ready prompt anymore. So I'll do A, J, just A and J. Just A gives you a target, J gives you that, and then just make sure you choose the right one if it doesn't say the same. Okay, and now we can do another one. A4, AO, I'll copy it to 580, I think. Yeah, I can kind of like be a bit silly with it, but yeah, it's just a way of copying memory to memory, right? That's just me messing about with screen RAM, but you can use it for like bitmap data or anything like that. But in terms of bitmap data, you do have this. This is a move bitmap block. So if you had two bitmaps, let's just do a bitmap here and another bitmap here, right? And this one I'm going to load at 8,000, right? And edit that. Make sure you create it. That will create the memory bank for it right up here, but it's clashing with the basic ROM, so I'm just going to unlock that. That will create the unlock, and now it should just write that data fine. Pretty sure it's fine anyway. There's just it just sort of does it if it has to. I'm pretty sure it does it internally. So okay, so that's now two sprite banks, and we'll do this. We'll call this one BMP source, right? So yeah, that's where stuff's going to come from, and BMP destination, right? So let's say I go into the source, and I'll do up the top left here the letter A, right? Or do a little ship or something. I'll just do a little spaceship sort of shape, right? It's not A now, it's a spaceship, believe me, right? And just to prove it, I'll do a little thruster, right? So I'll try and copy this data. Oops, I'm kind of missing a block a bit. See, it auto color corrects as well. Yeah, it's not letting me do it because these are a majority color now. But if I do, I'll just turn that off, turn off clean up, and you can do what you want then. Auto on, that's it. Right, you see it's telling me I've got color clash until I fix that. Right, and I'll do, since we're into this next tile, I think, yep, I can do some blue. Right, so there's a little spaceship. Okay, and come out of that. So that is, let me look at it again. That's 1, 2, 3, 4, it's 6 blocks, right? Now, at 4,000, this is the one that we're going to see. So I'm just going to do bitmap there, right? Choose the destination. That's the one we're going to see at 4,000, right? And I'll move that out just in a second, just so you can see it's just going to be a blank bitmap, right? There's nothing there, right? It will just be black, right? In fact, what I'll do is to prove it, I'll just call this, I'll just put in destination DEST, right? Let's do a little rounding off. Oops. Right, that's good enough for this test, right? So let's run that again. So we're just going to see the destination. Now, the reason I made this move bitmap block as opposed to just doing move memory, this works a bit differently because it needs to move color RAM and the D8000 color, like screen RAM and color RAM and all these extra things. Okay, so it does all that. So we're just going to move basically what's in the source, so 8,000, right? That's the pointer for that source bitmap, right? So we've got the little spaceship top left, and we're going to move that. Let's see, it's going to be that position, width of 2, and width of height, width and height 2 by 3. Right, it comes from the source at 0, 0, and it's going to land at the source. I'll move it somewhere. I'll move it to 4 by 4. Right, so we'll see it. We'll see it further down. We should basically see it. Just look. So round here somewhere. Right, I'll put that there like that. We should see it roughly there. Right, we can see what will happen. I'll do a little red X. So I'm curious to see what happens with the color and stuff. I think it's going to copy everything and replace it. So it's going to load the bitmap, it's going to copy this over to it, and that's what we'll essentially just see, right? I'm going to save it in case I get a crash, because it just tends to happen quite a lot for me. And let's call this bitmap move. Okay, and I'm going to hit F5. It's going to copy the color as well. We see that. Okay, we got a bit of chaos there. So I think even though this is here, this source is here, I still need to load it in, right? Even if we don't see it. So I do another bitmap and choose it, right? Basically, we're going to see this one because it will always do the last one. Pretty sure it will just switch to the last one that it touches. Hopefully. There we go. So it's loaded that little sprite in there, right? And it's sort of just cut into the shape that I made, 4x4, right? Later I'll make this a bit more interesting, like put variables in here so you can choose where it goes. You can mess about with lots of stuff, so you can basically take what was in memory. So you can move something out of the destination, put it somewhere else in memory, right? Ready to be replaced. Then you can move something and move it back, right? It is a bit of a slow, it's a slow algorithm. And just to show you the speed of it, let's just move this to 7x7, right? And I guess, well, you're not really going to see this so easily because it'll move and that'll be it. I'm just trying to think if there's a way to clear the memory. I don't know if I've got anything yet. I don't have anything to fill memory with, so that's the other thing. I could copy some junk over whatever, but let me do this anyway. I don't know how. Don't know how we're going to determine the speed of this. Right, see, it's just instant, right? So we just see it there. I mean, could you essentially make a game moving bits of bitmap? Sure, it'd be slow, but if you run it on the ultimate, it would be fast. So that's the idea. Like a lot of these things that are slow routines, they'll run well in the ultimate if you set it at 4 megahertz or higher. So a lot of this is geared towards that. I'm looking forward to games just being, better, faster, bigger because of this, but still feeling like a Commodore 64 game, still being something that you can strip back to make it run on a native Commodore 64. Either way, you either upgrade your game for an ultimate or you downgrade it a bit for a normal stock C64, or you just get it to work for both out the box. You don't have to do these fancy extra things. But you can see, so this is a routine that's 368 bytes, not too bad considering you're copying data around. And again, I will look to make this into a better routine where it carries vars, and that way it can do a whole lot of like lookup table stuff and move bits of blocks of memory around very effectively and cheaply. So it can build up a bitmap from bits of bitmap using two sources. That's pretty much it. That's where I'm at with it. I do want to bring in a kind of top bar menu here, just so that I can move things about and be a bit more organized. I quite like the way it is, but I do want a kind of bar here where I can put the file name in a slot, just to see it a bit nicer, and then some options like menu, settings, import, whatever it might be as this thing expands. But it's already good to go. I think you can make a game out of this, guys. So I'm giving you the green light to start making something. If something breaks, if there's a bug, if there's something not right, I'll hopefully be able to help you with your files. So you can get me in Discord and send it to me and I'll try and fix it. If there's a bug, I usually fix it the same day. I'm a bit persistent like that, where I just want to get things perfect and I don't like anything to hold anyone back. So tell your friends about this tool, get them into the coding vibe. Obviously you can code away absolutely everything, even there's illegal instructions in here if you're doing some kind of demo scene tricks. If you are a demo scener using this and you're using drag and drop, I would be very surprised. You're more likely to have the pro version and using code blocks. This all supports kick assembler tricks as well, like you can do the exclamation mark dot and it will give you that kind of shortcut loop. So you can do your BNE then you can just go for an exclamation minus and all that stuff. That's all in there. Containment loops as well. And if there's anything missing from any of the kind of terminology or the shortcuts that you want from other tools, let me know. I'll do my best to incorporate them. And yeah, I'm just going to keep working on this. As you can see, I'm giving you kind of a sneak peek to new features when you buy the Pro version. The interrupt shell, interrupts code, moving memory, and move blocks, and eventually there'll be a fill one there as well. We can fill a whole bunch of memory with either another bit of memory or just zeros or whatever you want. That'll be coming soon as well. And I look forward to people making games with us. Catch you in the next video, guys. Bye for now.